Hi guys, good morning. Today we're going to talk about slope and rate of change. So let's go ahead and get started. Vocabulary, slope and rate of change. Slope is defined by this formula, m equals y2 minus y1 over x2 minus x1. So that's two coordinates or 2 points. The ratio of change in the y coordinates to the ratio of change in the x coordinates, or rise over run. These are many things you might have seen called slope. This triangle here signifies change. It's a Greek symbol called delta, and it means change. So the change in y over the change in x. So there's many ways you can look at it. So here's my first example. What we're going to do is find the slope of this equation here. And when I look at this equation, I notice that it is in standard form. What might be easiest to do is to convert this from standard form over to slope-intercept form. So slope-intercept form is that y equals mx plus b format. Right now it's ax plus by equals c. Let's see what we can do to convert from standard to slope-intercept. First of all, I need my x to move to the other side of the equal sign, so I'm going to subtract 4x on both sides. And then I need to isolate that y, so I'm going to divide everything by -2. So y equals positive 2x plus 5 over 2. And I would say the question is asking for the slope. So the slope is the m in y equals mx plus b. So the slope is 2. All right, moving on to the next one. What we're going to do is find the slope given a table. So if you look at this example here, to find the slope given a table, find your change in the y value. So I notice I'm changing by 6 here, but by 12 and by 12. And the reason I only changed by 6 is because on the x side I only changed by 2, and I changed by 4 and by 4. So let's go ahead and see what our changes are over here. So my change in my y value here is -2, -1, -1, and then let's see my change here. My change is +4, +2, +2. So to find the average rate of change, we just need to make sure that these are proportional. 4 to 2 and 2 to -1, those are proportional to each other. So my change is the change in y's on top, and then the change in x's on bottom. So my change in y's, I had -2 over, and then my change in x, I had 4. So that reduced to -1/2. And also if I did it between these numbers here, then I would get -1 over 2, which is also -1/2. So my slope is -1/2 on this one. So another way you might have to find the slope is when you're given 2 sets of points. So when I have 2 points, I have to use my slope formula. And what I would do is go ahead and label those points as x1 and y1, and then the other point is x2 and y2. When I do that, I can just plug those values into my formula. It's subtract the y's on top, and then again x is on bottom. So let's see what we have. y2 is -2 minus 5 over, I'm going to x2, 0 minus -3. Be careful with that when I'm minus and negative. So what I have is -7 over 0 minus -3, or 0 plus 3 is just 3. Good. Next, this is one of the more fun ways to find slope. when I'm given a graph, I can choose any 2 points that are very clear, and when I find that point, they're dotted in a very specific place, they're not in between two values, I can use rise over run. So I like to start by finding a point on the left, and there's one right here, and then finding a point on the right, and there's one right here. So rise over run. Rise means going up or down, and how far up or down are you going? And when I do that, I need to take note that if I go down, that would be negative. If I go up, that would be positive. So I'm going to go down 1, 2, 3, 4. And then again, that's the change in my y values, down 4. And then my run, I'm going to go over 1, 2, 3, 4. So the change in my y values is -4. And then the change in my x values is +4. So when I reduce that, I get -1. Yes, I could have chosen different points. I could have chosen here or here. Any points that are very clear to me on the graph, you can choose. All right, here's a real world example. So I have a table here, and I need to find something. Let's figure that out. It shows the temperature of a solution after it's been removed from a heat source. Find the rate of change for the temperature for the solution. All right, so let's just go through our table and see what these values are. The difference between 143.6 and 139.4. 143.6, 143. 143.6 minus 139.4. Let me just make sure that's what that was. Is 4.2. And the difference here is clear to see too. And then I have the difference here would be 3, 3, and 4. So not all the values are the same, but we can keep going here. This looks like 6.3, 26. Let's see. 133.1, 126.8 is again 6.3. So I notice that that is proportional. So 126.8 minus 118.4 is 8.4. All right, so if you notice where it increased by 2, I had it increased by 4.2, and then where it increased by 4, which is double that, it increased by 8.4. So in this case, I'm going to just use whatever is easiest for me, which would probably be this first set, 4.2 over 2. The change in y is 4.2. The change in x is 2. And I would go ahead and reduce that if I could. So I would get 2.1. So my slope is 2.1, or my rate of change is 2.1. It would be 2.1 degrees per minute. 2.1 degrees Celsius per minute. Make sure that your answer makes sense in the context of your word problem. Finally, there's another real-world example. So we're going to refer to this graph and find the average rate of change for the sales in both digital music and ebooks from 2004 to 2009, and we're going to compare the rates. So let's look at first the digital music. Digital music. So first of all, our change in y, so my y is here, so that would be my millions of dollars. So, and 2009 would be this right here. So 3,100 minus, let's see, in 2004 is 200 over, I'm going back to 2009. minus 2005. So if I subtract those, then I would get 2,900 over 5, which turns out to be 580. So that would be $580 million per year. And as far as ebooks, again, let's look at 2009 and 2004. So in 2009, they sold 165.8 millions of dollars worth of ebooks, minus the 9.6 million that they sold in 2004. And then I'm going to go back to those years, 2009 through 2004. Sorry, this was 2004 here. So I would get 156.2 over 5, which turns out to be 31.24. And just make sure your answer makes sense in the context of the problem. $31.24 million per year between 2004 and 2009. And compare the rates, I would say that the rates for digital music has increased dramatically from 2004 to 2009. And then for ebooks, it did increase between those years, probably because technology got better. All right, that's it. Thanks, guys.